Good morning, everyone. Right now, a crisis grips our nation, while our youth hangs in the balance. After a hard-fought public victory over smoking, the specter of childhood nicotine usage has once again seized the hearts and minds of teens across the country. Even with nicotine on the rise, we've seen more debilitating drugs become more prevalent as well. Especially in our home state of Wisconsin, we've seen an incredible rise in opioid-related deaths. We've seen a 30% rise with 926 deaths just in 2017. We've also all seen the ad campaigns in our schools and our billboards and on TVs that are anti-substance abuse, but more has to be done. This is a problem that needs attention, and that's exactly what this year's challenge problem focused on. We were asked to create results that would help assist the fight against the spread of substance abuse, and we've come up with 3 parts. In part 1, we predicted the spread of nicotine use through vaping over the next 10 years. In part 2, we took a class of 300 high school seniors and modeled the prevalence of drug use using a system of multipliers. In part 3, we created a singular and robust metric to analyze the effects of certain drugs and to what extent they impact the user. We hope that our findings will help assist professionals combat the spread of substance abuse. Now Ryan Mortensen will present part 1.
So for part 1, we are asked to create a model to predict how nicotine use due to vaping will spread among high school students over the next 10 years. And then we must also compare the spread of cigarette usage in the last century. Now, we focused on high schoolers because they're the most at-risk population, both for addiction and for permanently changing their neurochemistry due to addictive substances like nicotine. Additionally, we decided to look at how cigarette usage would increase due to the rise in vaping, because that's also something we're concerned about. So this is a chart of the historical rise and fall of cigarette usage from 1900 to 2012, and we use this as a basis for our model because both cigarettes and e-cigarettes use the same active ingredient, which is nicotine. So we believe addiction rates will be similar. And additionally, there are similar campaigns against both. There were fierce anti-smoking campaigns, and there are now fierce anti-vaping campaigns. And finally, we analyzed this graph to be generally the shape of a bell curve, which determined how we ran our regression to create a model. So these are the percentage of high schoolers vaping from 2011 to 2018. And so the year 2010 equals 0, and throughout part 1, the year 2010 is 0. Now, we decided to run a Gaussian regression on this data, where V of t is the percentage of high schoolers vaping with respect to time. And that model resulted with an R squared value of 0.83, which we're very happy with, and we feel is a very strong correlation. And then the graph you see there is our model from 2010 to 2035 of the percentage of high schoolers we expect to vape. And so as you can see, it peaks at around 2023 with about 32% of high schoolers vaping. Now, to turn this model into, or to find a conclusion, we first turned our model into a decimal, and then we multiplied it by the graduating class each year. And the reason we do this is so we count each person once and only once when they graduate. And then finally, we multiplied that number by 0.95 because through our research, we can expect 5% of students will be able to quit, leaving the remaining 95% who will continue to use e-cigarettes throughout the 10-year period. And then the indefinite integral gives a total of the total number of new e-cigarette users as time progresses. Now, to find a concrete result, we took the integral from 2019 to 2029, and then additionally, we added the freshman, sophomore, and junior classes in 2029, because since they have not graduated yet, they are not counted in our model, so we had to add that on. And then we found that over 12 million new e-cigarette users will occur between 2019 and 2029, so in the next 10 years. Now, even more concerning than e-cigarettes are cigarettes because they contain even more harmful chemicals and even more carcinogens. And we found that someone who uses e-cigarettes is 4.78 times more likely to use cigarettes. So applying that to the data we found through research of the likelihood of a teen using cigarettes, we found how many students will use cigarettes that would have never used them before because they vaped. And so that number is 29.4%. So we multiplied our previous results by 0.294 to find that over 3.5 million kids will begin smoking who would have never touched a cigarette, but because they tried vaping, they now try cigarettes over the next 10 years. Now, our model is validated because we found the peak to be about 32% of high schoolers vaping, which is very similar to the historical peak of cigarette users 45 years ago, which was 29%. And since they have similar addictive ingredients, we can also assume that they will have similar trends in addiction. And then finally, our strengths and weakness is that we measure high schoolers. This is a strength because they are the new generation and they are the most at-risk population. But this is also a weakness because there are plenty of other people who are also at risk to become addicted, and the brain doesn't stop developing until you're 25. So there are other people to take into account. Now, Gabriel Grolnick will present part 2 of our problem.
So, in part 1, we created a model to predict the spread of nicotine usage due to vaping and the number of new cigarette users over the next 10 years. And this model is great for analyzing general trends and national levels of cigarette usage. However, what if we want a model that can be more localized to a specific person or a specific location? For that, we need to create a model to predict the likelihood that a given person will use the given substance. Our model specifically analyzes nicotine, marijuana, alcohol, and unprescribed opioids, and then we validate this model by testing it on a class of 300 high school seniors. So in order to create this model, we realized we needed to determine first what factors we would analyze as contributing to a person's propensity for drug use, and we limited our model to gender, race, and the races we analyzed were white, African American, Hispanic, and then all other races as one category, age, school performance with grades, parental level of education in terms of high school or college degree, family income, which is per person, so it's the total divided by the number of people, and then peer influence, which we defined as the total number of peers who use or abuse any sort of drug. And also, we needed to make several assumptions about this data and about how our model was going to work in order so that it could be feasible and within the time that we had. So we assumed that the effect of a factor in determining the likelihood for a person's drug use is independent of other factors. So for example, we assumed that the effect of a high schooler's income level is not going to influence the effect that their gender has on drug use, and vice versa for all of the factors. We also assumed that nicotine, when mentioned in the problem statement, would refer to either traditional smoking methods and modern vaporizers, because for some of the data we were looking at for factors, it had one or the other, not necessarily both, so we used whichever was available. And then, so for our system, to create our model, we decided to use a system of multipliers, and basically the idea of that is that one person is a certain number of times more likely or less likely to use a certain drug than another person. And the way these were calculated, and I have an example for gender here, is that we found national average percentages for each factor, so females and males who would use these drugs, and then we divided each attribute by a factor by a control one. So for gender, for example, we used female as the control and set it to 1. So according to the National Institute of Health, for example, 19.7% of high school boys drink alcohol, whereas 20.5% of girls drink alcohol. So then using this division, we find that males are 0.961 times as likely to drink alcohol than females. And then we found the multipliers for each factor for each drug. And so to create the overall multiplier for said drug for the person, we multiply all of the individual multipliers, and that gets us a value that can be used in our probability statements, which is used in our model. And basically the way we calculated the probability of a person to use a drug is that we took the national average percentage of high schoolers who use that drug, and we divided it by the overall multiplier for that person, and that creates a value between 0 and 1 that we then, in our model, we can generate a random number from 0 to 1 and then compare the two, and if that randomly generated number is less than this p-value, then the person has used the drug according to our model, and if it's greater, then the person hasn't. And so using this, we then moved on to the task of creating a system to generate a class of 300 high school students and run our model on it. And we had to make several assumptions about that because the problem statement did not refer to a specific location or demographics of this high school. So in order to conserve time and make our model feasible, we had to assume first that gender and grades would be distributed equally among a given population. So like in a class of 300, there's 150 males and 150 females. And we also assumed that for all of the other factors, each person has a specific chance of presenting one attribute of a factor that's proportional to the total number of attributes for that factor. So for example, as I mentioned earlier, we analyzed 4 races, so therefore each person has a 25% chance of being any given race. And so for our model, we decided to use a Java program due to the complexity of generating a class of 300 students and then running our tests on it. We decided to simplify it by having it run itself, kind of. So the way our program works is it first generates a class of 300 seniors and stores that in an array, and then it runs the test on each person for each drug, creating a Boolean array of whether that person has used each drug. And it uses this by each person, which is a class that we made, storing instance variables that relate to the factors, and then outputs those results in the main method. And so in 100 tests, because we had it run 100 times, of 300 student high school senior classes, our model outputted that on average 199 would use nicotine, 16 would use marijuana, 31 would use alcohol, and 8 would use opioids. And then if we compare these results to the national averages, we find extremely high or negative percent error values. And while these seem frightening and like worrying about the quality of our model, they actually more demonstrate its strength than its weakness, because our model these results are consistent with the assumptions I outlined, because edge attributes for each factor are weighed equally to the other ones, so this can inflate and deflate. For example, all grades are weighted equally in this population of students, which means that lower grades, which are more likely to use certain drugs, are more highly represented, and higher grades are lower represented, which can cause the values to shift. So in keeping that in mind, our model is consistent with those results. However, a major weakness of our model itself is that our data was gathered over various time periods and from various sources, so therefore it doesn't really account for any shifts in time of the likelihoods of different people to use different drugs. And now Severe is going to present part 3.
All right. Thank you, Gabe. So in part 1 and 2, we were asked to measure the spread of drugs among high schoolers. But in part 3, we were asked to create a model for the impact of substance abuse that includes both financial and non-financial factors. We must use this model to rank the impacts of alcohol, marijuana, nicotine, and opioids. So in order to simplify this process, we decided to separate the impacts into 2 categories. The first category is primary impacts, which are impacts that only affect the user of the drug. These impacts can be things like the cost of the drug, the medical expenses due to drug use, and the shortened lifespan due to drug use. On the other hand, tertiary impacts are impacts that affect those around the user of the drug. So these can be things like family members taking time off, domestic abuse, and cost to taxpayers. So for our metric, we decided to use time, specifically hours lost in a lifetime. And in order to do this, we had to find a way to convert fiscal costs into time. So we chose to do that by dividing the cost by the average American income per hour, which is approximately $16. Once we did that, we added that to the actual amount of time lost due to the impact to get our adjusted time lost for each impact. However, for tertiary impacts, we had to modify the equation slightly to account for the fact that more than one person is being affected by each impact. So we chose to multiply this by the number of occurrences for each impact. For example, if each drug user cost an American taxpayer 1 cent, that 1 cent would be multiplied across the entire American taxpaying population. So for our results, we found that opioids by far were the most impactful drug, taking off around 44 years of your life, followed by nicotine, followed by alcohol, followed by marijuana. And multiple surveys that we have found to support this ranking of drugs. And our 2 major strengths for our model were the accessibility and the potential for growth. This is a very as we like to say, layman's model, where any common person can understand the impact of 44 years being taken off your life due to opioid abuse. And also, with more time and research, we can add more impacts to our model to get a more accurate result of the impacts of drug use. However, our major weakness was that our model does not include the emotional cost for a certain impact. Ultimately, emotional costs are so subjective that no mathematical model could ever accurately portray these emotional costs. So this takes us back to where we started, where we were asked to what extent is substance abuse impacting the lives of individuals in modern society. And I'm not going to lie, at this point it looks bad. Part 1 shows that drug abuse is going to get worse before it gets better, and part 2 shows that a large proportion of high schoolers will use drugs drugs, and part 3 shows that drugs take literal years off of your life. But there is a light at the end of the tunnel. Part 1 shows that although it gets worse, it will get better, and with the foundation we have laid out for you, we are certain that we can combat this specter invading our schools. And if you don't think we can, I find your lack of faith disturbing. Thank you, and we are open for further questions.
Thank you, and congratulations for getting here. I have a question about your question 1. You were looking at the percentage of smokers and noticed that it looked like a Gaussian curve you predicted that in terms of vaping based on cigarette use. And from that, you calculated the total number of people who would be using vaping products. How did you get the total number of people who would be using vaping products by integrating that particular curve?
What?
I can answer this. Yeah. So then I am the one who chose to integrate. So ultimately, what our first model shows is the amount of high school seniors each year that vape. So then we chose to think of that as the change of vapors in a given year being a positive. So then it made sense to take that annual change and to integrate it to get the full amount of vapors that are added on each year.
Can I just ask a follow-up on that same question? So you integrated this equation. How? How did you integrate it?
We used Wolfram Alpha and we integrated the Gaussian curve that we were given, and the curve that we have is what was basically given to us through that program.
So it was numerically then. So this is a estimation or an approximation of the value as opposed to?
Yes.
Okay.
I have a question about the peer pressure factor. So this is that S of P, peer influence. It looks like you have 2 possible values for peer influence. One for when you have 4 or less than 4 alcohol or drug using friends, and 1 for 4 or more. And I kind of have 2 questions. One is, how did you choose the numbers that were in this table? And then the second is there a reason for like some magic number 4?
This is actually for all of our factors. The attributes that we use, that we analyze, were really just what we were able to find using research. So we found studies from the CDC and the National Institute of Health, as I mentioned, that basically analyzed for all of these factors, and that also was part of limiting our model to the selected factors. It was all a question of what we could find data on for percentages of high schoolers that was only restricted to the factor we were analyzing. So when we were researching for peer influence, we knew at that point that we wanted to do it as number of friends and peers, and the research that we found that's related to that topic had 4 as the number. And I think it's just because when you have friends who are using these substances, when it's just one person, that's not a super strong influence. So 4 specifically isn't a magic number. It's just that's a guideline for past that point. Well, that's a whole circle of friends who are using those drugs, so then it can play a large role.
So the actual numbers that are in the table is some percentage that was...
We took the percentages we found in research, and as I mentioned, we set a control attribute, and that's the one that's listed as 1 for all of the drugs, and then we divided the other attributes percentage of high schoolers by that control one, and it produces that multiplier of likelihood.
Thank you. Karen kind of stole my question because I was also excited that you had the peer influence factor there. And so maybe you can talk about, I understand that you had it between 4 and 4 friends, or less than 4 friends or more than 4 friends. So how did you, within your simulation, assign those values?
It was basically, as I mentioned, one of the assumptions we had was for all factors besides gender and grades, it was just the total number of attributes for each factor. So for example, race, we had 4, or the peer influence, we had 2 possibilities, either less or more. So then each person, when we created them in our program, we used a random value. It was either, if it was less than 50, it would be no friend, less than 4. If it was more than 50, it would be more than 4.
This is a question from Cleve Muller being phoned in here. You were using a Gaussian function to model the number of new people, is that correct?
Yes.
Why are you using Gaussian for that?
So we did that mainly by looking at the historical rise and fall of the percentage of cigarette users as a percentage of the population, and we thought it looked most similar to a Gaussian bell curve. And then additionally, while we were working through this problem, we did try several different types of curves, and the R-squared value for the Gaussian bell curve was the strongest, so we decided to go with that. And it also, just in the context of this problem, makes the most sense, because with addiction, it's something that starts off sort of small, and as you have more friends, suddenly the rate at which more people adopt it accelerates. And then once campaigns against vaping, which have already started, we already see ads now for stop using e-cigarettes, they're bad for you, that's gonna cause it to go down. So in the context of what we're talking about, it also makes sense.
Sorry, in your factor for income, you divide by the total number of people in a household. So that's basically saying that a family of 5 that makes $100,000 per year is the same as one person making $20,000. Could you comment on that? And do you really feel that way, or is it?
Well, I mean, again, it was really like we found we were trying to do socioeconomic income, and as we were researching for that factor and how it influenced drug, the study that we found that we most thought was most credible from the most controlled, in the sense that it was only analyzing that factor. That's what it limited it. That's what it analyzed. It analyzed income brackets in terms of per person income. And I don't necessarily know exactly why that study chose to do it. I think that maybe overall family income might have been stronger, because that might be more reflective of how much money they're able to spend. However, that's just the survey that we found and the research that we had gave us that.
Thank you very much.
Thank you.
Thank you.